Well, hello everyone. Welcome to my session. And I know after 2.5 day sessions, it's getting very tired and you just want to go home. And this is also after lunch, so I'll try to do my best to keep your eyes open, okay? The topic today is about developing the next generation enterprise web app. Before we jump into agenda or introduction slides, let's just look at the title for a few more seconds. I got 3 hidden messages embedded in the title. And the first word, well, 2 words actually, is a next gen. Well, you're talking about next generation, you must have a current generation. I work for SunGard, and SunGard is a large company. I work for the asset finance division. And we own a product that's doing the asset finance, the leasing, loans, the mortgage, those sort of things. And our clients, and the app was initially written in early 2000. That was still in the .NET 1.1 era. It has gone through several upgrades and go to the version 2.0, 3, 4, 4.5, but it still stays as a desktop application and using Windows Forms. The next generation, of course, when we're talking about web app, we want all the buzzword. We want it modern, we want responsive, mobile first, cross-platform, blah, blah, blah. The list goes on. Okay, the next keyword is the word enterprise. It's a large financial application. Our target clients is large corporate and large financial institutions, including first-tier banks. So our application is really complicated. We'll go into more details about that later. But for now, we have 4 million lines of code and more than thousands of Windows forms and user controls combined. Okay. The last word is about developing. How do you develop the next-gen web app from the current generation Windows Forms application? I've done some research when we started up this project, and I Googled it and say, is there any easier way, any silver bullet to magically convert my Windows app to web app? I can imagine what the answer would be. But I'll split the answer in 2 parts. Many people agree that for the back end, your business logic, if it's well written, if it's encapsulated well, it can easily be migrated to, say, web services or other components that can be easily reused. I fully agree there. But what about the UI? From Windows UI to Web UI, you can see how many hops that's jumped. So most of people say that it's better just to rewrite. And I quote, any naive attempt to migrate a Windows UI to Web UI may end up with unusable application or have a really bad user experience. And I also agree. A naive attempt to anything could be disastrous. So what about non-naive approach? So that's way between migration and the rewrite. I think at the end, we choose to we choose to migrate, and I'll explain the reasoning behind it. And after the project has been run over 1.5 years, almost 2 years, I think, and I can confident to say that migrating Windows UI to web can work. Before we go into technical details, I'll just briefly introduce our business. Already mentioned, it's a global leading provider of the leasing and financing software system. It provides end-to-end systems, so there's no need for our clients to buy other third-party systems to integrate. We have more than 100 employees across 3 dev centers. So having that context, let's look at the challenges that we face. The very first thing is that our clients is coming from all over the world, from European, from America, from Asia, and we have to play by their tax rules, regulations, even terminologies are different. So we have, over time, built up a lot of switches and flags in code and make the code really complicated. And complicated business logic that drives the complicated UI logic. Sometimes you want to hide fields, sometimes you want to make fields enabled, disabled, and all driven by the security roles. Just a few examples say why the UI is so complicated. Cyclic dependencies and defaulting rules. And we have more than 1,000 or almost 1,000 of security roles. So we have quite a few people that worked with the product since day one and developed the product from scratch. And not a single people in the company that can say that I know everything about this product. Normally, quite frequently, we have fields that's disabled, and we want to know why I can't interact with it. I want to make it enabled. And there's no single people in the company can tell me what to do to make that enabled. So we all have to look into code and follow the logic, if else, and derived classes, and those sort of things to find, those are the half a dozen conditions you have to satisfy. And because the UI is developed over 10 years, or more than 10 years, and different developers, different designers that are coming on and off the project, and the UI have different patterns. That makes things more difficult. I'll just show you some of our screenshots. Right, you think that's a lot of fields and tabs, and try to look at those ones first. Many things are disabled, and you've got conditional logic buttons behind it. It's very complicated screens. Honestly, those are the two most complicated screens that you put on in here. So this is our first challenge, how to address the complex UI logic. The next problem is about existing employees. So we've been constantly hiring developers, and mostly .NET developers. They work in C# and they know how to write desktop applications. That's cool, but when you move to a web environment, they're not familiar with HTML. They've never written any JavaScript before. They don't know how to use CSS to do styling. And also, they're very new to this new responsive design. Maybe not so new now, but to them, they don't know much about responsive design. They don't know what mobile first means. But it doesn't matter, they can learn. But do we have anyone here that's from the .NET background and now is a web developer? Can you raise your hands, please? Quite a few. So you feel the pain. It's a very steep learning curve. You have to learn all those technologies and really master them to understand what's going on if something fails. So that's our second problem, how to take advantage of existing employees, especially developers' skill set. I already mentioned this. We have 4 million lines of code and 1,000 Windows Forms. We have 12 developers and 8 testers. So you may think it's a decent-sized team. But let me just throw you two other numbers. We have 29 other developers that are still actively developing in Windows product. They're adding new features based on a client request. They're fixing bugs from the support desk. We also have 28 other testers that are actively scripting against the Windows product. And we're trying to migrate simultaneously at the same time. You can imagine the challenge here. The longer we run the project, the bigger the mess, and the higher the cost to maintain the two products simultaneously. So the very real challenge is how to efficiently and quickly convert code. As soon as we get everyone move off Windows, and they can start using web, and then all the fixes and features that goes into the web product, and we can forget about Windows. Lastly, but not least, let's not forget our QA engineers. Do we have any QA engineers sitting in the cloud? No? All developers? Okay, it's a developer conference. But don't forget our colleagues. And we have 1 million lines of test scripts, and a single run of all UI scripts takes about 720 hours. You say, oh, just farm into the cloud, maybe done in 1 hour or whatever. But that's not the point. The point is the company has significant investment in the QA script as well. And if you rewrite the app from ground up, and you might have to rewrite all the QA script. So how can we leverage existing UI script and make them work with the migrated product? Okay, so those 4 challenges are real challenges. And let's see how we're going to address them. The solutions. Let me just quickly go over the technology stack that we use. In the Windows-based product, we use 4.5, already mentioned. It's a pretty standard N-tier framework. On the client side, we use Windows Forms. On the server side, we host it in the business rules are hosted in the Windows services, and they talk through the .NET remoting. For the web app, we use ASP.NET MVC and SignalR for some real-time message. On the client side, we use Twitter Bootstrap, Durando, jQuery, Knockout, and TypeScript. And anyone here uses Knockout or heard about Knockout or play with it? Good, because I'll be showing some demos using Knockout. And I'll explain why we use TypeScript later. When you were looking at the forms I showed earlier, you saw like many text boxes and drop-down lists and checkboxes. They are the primary residents on the form. So if we can get them converted quickly, that's the first priority. That's the most job done. So let's just look at this little form that captures address information. And as no-brainer, you map into a view model class. You define a bunch of properties, strings, integers, whatever. But I want to highlight those 3 fields. All 3 fields in C# are string fields. But on the UI, they look different. 2 of them are text boxes, single line, and one of them is a multi-line text box. So where do you think you want to put that logic? You want to put that logic in the control builder and tick the property checkbox saying this is a text area or it's multi-line. If you do that, then if you want to put the same strict information in another form or in a different format, you have to remember to do that again. Or you can say, I'm going to wrap this into a user control and just reuse this user control all over the place. Well, that's cool. But what about the next time? Then you may want to put individual information out of it or do a horizontal versus vertical flows. And then you have to remember doing that again for a different user control. Or if our clients are writing their custom UIs and talking to our API, they also have to know that for this particular field, I need to use a text area. I need to do some special logic handling. So what we want to do is to do this. I want to use this attribute, .NET attribute, to decorate the property and give this additional semantic meaning. And can anyone tell me where the data type comes from? Did I introduce it? It's actually from the .NET framework. It's from system.componentModel.data annotations namespace. And in fact, that namespace offers a lot more attribute. For example, the attributes to add semantic type information, whether it's a text, a multi-line text, password, email, because they all map to the string properties. And it's a primitive. It doesn't have additional meaning. So this brings those extra information. And we also have state attribute to talk about enabled read-only. And we use display attribute to render labels, captions, placeholders. And validations attribute. You're probably more familiar with that. Okay, another question here, a quiz. There's 2 of them sneak in, but they're not actually from the .NET framework. Can one tell? Yes, visible. Another one, enabled, right next to it. So they're not from the .NET framework. I added it there. What happens then? What can you do? You can invent your own attribute. It's not hard. This is just what I did. I created a visible attribute class inheriting from attribute, and I put it onto the property. And there you go. I can attach to the properties and give them semantic meaning. But so you may ask, what's the point? If you want this property visible, you want a control to be visible, just create the HTML and write it or drag and drop the control onto the form. If you don't want it to be visible, you just get rid of it. But it start making more point once I modify it a little bit. Let's say the county control should only be visible when country is US. Just as an example. So I can start putting conditions in those attributes and make them work dynamically. As another example, maybe state control. I want the label to appear as state if the country is US, and I like the label to appear as province if you select Canada. or China, or any other countries use this label. So you can do some of the smart logic like this. Okay, the next thing, after I define them, what do I do with them? Because they are .NET attribute, it's very easy. You just use a reflection to pull the information out. And what we do with that information is to generate a JavaScript object. As a JSON, we send down to the client. So this is another example. A driver license only enabled when age is greater than 15. This generates into this JSON object. It captures all the information. You've got driver license in here, property name, and got the control state. You've got dependencies, age is greater than 15. You've got everything here captured. So what we do next, on page rendering time, you've got a metadata object. You get the real data that you downloaded from your APIs or web services, and we combine the two. So we walk the object graph side by side and identify the dependencies and dependents and hook up value change notifications and to generate code that can run dynamically. So this is what we generate. Well, not really, but this is what generates dynamically at runtime. So this is using knockout syntax. So I'll just briefly explain this if you're not familiar with knockout. So what's really going on is that we extend the driver license observable with enabled. And the enable, we create a new computed observable that returns true or false. And the expression that we used is greater than age 15. So we know how to do this greater than operator, and then we can get a Boolean value out of it. What's important is that the knockout automatically tracks the change of the age value. So whenever age changes, it reevaluates this computed observable and gets you a new value. And then the new value is assigned to the enabled, which is also observable. So if you have a control state that binds to that enabled property, then the controls becomes enabled and disabled based on the change of age value. Okay. I'll show you a demo, what I mean by that, and how that works. Okay, I created this snippets or test demo app in the JS Fiddler. On top is just a bunch of UIs you don't have to worry about. What's really interesting is in the JavaScript. At the top, we just define an empty model. It's very easy. In here is the metadata. I mentioned just get generated using reflection and sent to client. And it's got all the information. In here, I say age is only visible when name has value. And driver license is visible not only when name has value, but also when the age is greater than or equal to 16. Okay, so this is sent from a server and auto-generated. This bit is that the framework code that you have to write, or initialization code you have to write. So we create a dependency manager, and we initialize passing in the model and the model's metadata. We'll go into the initialize method just in a second. And then we call the knockout binding, so apply binding, apply the model to the view. And it will automatically bind everything and displays. And down below here, just a snippet to simulate the data loading. You're talking to your web API or web services and downloading the data. Or introduce a 2-second delay here just to see how this thing works in app. Okay, that's all you have to write. So you see the field is started up as one field, and then you download data, apply the mapping, and suddenly age becomes visible. The driver license still disabled, it's still invisible, but if I set age to 19, that becomes visible automatically. Did you see I use any knockouts or jQuery to manipulate the states of the controls? No. That's all done by this dependency manager. And this is the code that you have very experienced JavaScript developers to write, and only have to write it once. So in here, I have a bunch of functions I can define, and those are very quickly written. And if it's for production, they need to be refactored and doing those error checking and sort of thing. And here we have two extenders, the visible extender, enabled extender. Okay, here's what I was talking about. When you have both the model and the model's metadata, you go through field by field in the model, and you try to find the same field in the matching field from the metadata, see if you have the dependency information there. And then you generate some code and hook them up. And you see here, there's no specific logic, there's no hidden, no visible, no property names that's mentioned in here. That's entirely generic. Okay, let's just try something. For example, if I add additional attribute in C# code, and this gets auto-generated, let me put another condition here. I can't remember. Let's just do that. I might have a, sorry. Okay, so added this enable condition. The driver license only become enabled when age is less than 99, but it's also combined with a visible condition, so that's currently hidden. If I set to a value, that becomes visible. If I set a value, then that's greater than 99. Maybe, hang on. Do I have less than here? I do. It's not quite working. Did I? So maybe I got the conditions wrong. So in this example, I added this edge is less than or equal to 100, let's say. So if I was greater than 100, everything else is the same. So this is the new condition added. I'll copy this and just to prove that's actually working. Not quite. Okay, something gone wrong here. Maybe it's because of my functions got some problems. Yeah, but you can see in another example, exactly the same stuff. So what's really beneficial is that apart from some boilerplate code, like the default models you would create anyway, and some of the initialization code, that's all you have to write. So the good advantage, the pros of this approach is that it's very suitable for simple UI logic, field level, one condition greater than, less than, or even starts with if you can write the JavaScript function to do that. And once the generic plumbing is done, you don't have to write any JavaScript code at all, apart from the boilerplate, which can be like embedded into partial view and get downloaded for every page. So .NET developers don't have to worry about writing JavaScript, doesn't have to worry about learning jQuery. And they stay with familiar technology, and they become efficient. I bet you've been thinking, wow, that condition is too simple. In real lifetime and in our app, it's never going to be simple like that. You're right. It's very difficult to express complicated conditions. What happens if you want to do or, ands, brackets? You can't do that very easily using, say, the attribute. And there are also lots of magic strings, magic numbers you have to deal with. It's not very friendly to refactoring. And if you have have the same condition want to apply to multiple multiple properties, you have to copy and paste that multiple times. And if you want to refactor the condition, you have to remember to refactor them multiple times. Finally, but not least, is that you saw the for loops that's run at page loading time. So it will slow down the page load, increase the CPU usage, increase the memory. So reduce your performance. Okay, let's try to improve it, right? Let's not try to give up yet. So now we refactor this. Instead of expressing the conditional logic inside the attribute, we try to put it out and put it into an actual C# method and just have the property, the attribute referencing the method name. And then, because this is in the C# code, developers can just use all the C# constructs. You can use ands and ors and brackets, loops, if conditions, and also less magic strings. So you still get one remaining magic string there. It's not very friendly to refactoring, but we'll deal with that later. And then if you have multiple properties that want in the same condition, you still have to copy the attribute multiple times, but at least you don't have to copy the condition. And if you want to refactor the condition, there's only a single place to go and do that. So what do we do? Because the condition is inside a method. You can't use reflection to extract those. So what we do, we use Roslyn. So how many of you have heard or played with Roslyn in the crowd? Great. We use Roslyn to automatically parse the method bodies and generate the equivalent JavaScript. Oh, sorry, not JavaScript, TypeScript. So similar stuff. This is actually put from a real code that we have. Instead of dynamically generate something that in memory at runtime, we physically generate the snippet into the file and save onto the disk and deploy that file together as the product. You might see there's no difference. You still got knockout extension syntax. You still have visible. You got conditions in here. But this is auto-generated code. There's no more runtime plumbing. So this is just like developers physically written that function. And there's the code generation to TypeScript that really helps to constrain what the developers can write in C# code. If they write system.io.file.read, and certainly you can do that in C#, but you can't do that in JavaScript. And if that code gets generated into JavaScript, you will get runtime errors. But if it's generated into TypeScript, which then compiles into JavaScript, if we don't provide that function to do file read, well, I can't imagine how you're going to do that. And then the TypeScript compilation will throw errors, and the developers will have compile time feedback from this. The benefit is that the developers, well, .NET developers continue to write C# code, not JavaScript, not even TypeScript. And code generation is rerunnable and replaces the generated file on each compile. And we can easily integrate it into MS Build, into our CI, and to do this for consistency. Okay, now let's talking about a QA script. I had this code up here, abbreviated, but then we have QA script down below. The QA script previously interacted with Windows form controls. They expect to see properties such as text, labels, visible, enabled, all the other, say, control properties. We don't have control properties. We only have strings, integers, and booleans, those sort of things. And we all know that they don't have properties called visible, enabled. So the QA script cannot talk to our code directly. So what do? We use the same mechanism that we use for generating TypeScript. We generate a .NET proxy. We call it internally called .NET proxy, and basically just a wrapper around the base model, and providing accesses to the underlying values, to the visibilities, to enablement, or to captions and labels and placeholders, those sort of things. So you just basically analyze your QA script, what properties that they interrogate, doing a cert on, and then we generate the corresponding properties in here. And then the QA script can quite happily talk to the generated proxy. I'll see if I have time at the end, but I'll show you another demo. But we want to take it to the next level. We don't stop using Roslyn there to pass the simple conditions in the meta body. That does the job, but not very fun and exciting. What's really exciting is that we actually use Roslyn to analyze existing Windows form code and really go into branches, if-else branches, go into for-each loops, go into base classes, go to derived classes, go into overload method to extract all the logic, all the UI logic. And we auto-generate those attributes there and auto-generates the method pointed by those attributes. Of course, the generated code won't be compilable. We're not there yet. That requires a significant amount of work. But it really helps uncovering all the hidden logics that have been put in place over the decade. And really helps developers to identify to answer the question, how do I make this field visible? How do I make it enable so I can put in some value and start testing? Because before, we couldn't answer that question without really have to go into deep clean code. But this Roslyn helps us do that. You may think I've been talking about all the high level and in the la-la land and not really have anything really hard to apply that to a real project. But I tell you it's not. We've been running this project for a year and a half, as I mentioned earlier, and we use exactly the same technologies I mentioned in here, even though the conditions are much more complicated and the scenarios are much more sophisticated. So we have Windows Forms on the left, and the converted web forms on the right-hand side. And with very minimum code change, or the UI code on the client side, what developers can quickly get the form done within a couple of days. And there's another model dialog. Another one, this one's more complicated. It's got lots of disabled field. And we also have disabled, I can't get a full screenshot because that's quite difficult. Can you see the disabled fields? You can see that those fields are disabled. They have very those opacity applied to it. Even more complicated forms like that, and we can convert that quite easily. So have we addressed all four challenges? I think we do. Now we use metadata to address the complex UI logic. We embed logic inside C# code and push them out through code generation. And we taking advantage of existing developers' skill set. They're working with familiar technology. They're efficient, they're fast. They can convert code quicker. And then we leverage on existing UI test script. So the our QAs don't have to rewrite all the scripts. Well, they still have to make modifications, but those modifications can be largely done through regular expressions or other minor changes, or they change their library, their core library, to start talking to some other API, to a new API, but the rest of the script can stay unchanged. So I can say, migrating Windows UI to web can really work. And by combining a few techniques, like metadata, Roslyn, TypeScript, we made it work. And I believe if you have applications like this, or maybe even slightly simpler, then you can make it work as well. Before the final demo, I just want to say that there are a couple of related Ignite sessions. Unfortunately, this is the last session, so you don't get a chance to go back to them. but I believe those sessions will be put online. So if you are still interested, you can go online and watch them. And find me at the final closing drink. Okay, so if you want to stay, I'll show you the demos that we, the version 1, the version 2 of metadata. This is put from the real code. It's a real project solution. I hide all the rest of the stuff and just show those 4 files. I created those test data and test pages just for demonstration purpose. So I have this test object. It's coming back from WCF Web Services, so they have those data contract attribute. But what I really want to show here is I got a visible attribute, a property called, a method is called is something visible and return a Boolean. This is a static attribute. The attribute can be static. You want this to be read-only all the time. That can stay read-only all the time. It doesn't have to be always dynamic. If you want this to be dynamic, use the same sort of similar condition here, age is greater than 16, then it becomes enabled. So if I do a compile, I already done a compile earlier, so it will generate this. So this is our dependency manager, and I've got a method called initialize. This is in TypeScript, if you can't tell. So it's got imports and class and all those sort of things. Look, if you worked with TypeScript for a while, you feel like it's really similar to C#. At least that's what I find. So what's interesting is here, so the top is some boilerplate code that we use for other purposes. What's really interesting here is those get generated automatically, just like I've written in JavaScript earlier. And on a UI, we have some control form builders. So you say, I want to render the control for name, email, age, blah, blah, blah. And in the TypeScript that your form binds to, there's an initialize method that for downloading data and doing the initialization boilerplates. And you can say, oh, I'm just simulating a data load. So so this data, well, ideally in real time, in real life scenario, it comes from the server. And we just pass this into the dependency manager to initialize. And this is coming from here. So that's how everything wired up together. And when I run this, I'm just waiting IS the worker process to start up. Okay. So member scenes. Well, I said it's a read-only field, so it stays read-only. Can you see the shadings in the text box? You can't really see the shading, but I can. On my screen, it's got a dark background, and a gray background, so it indicates that the field is read-only for informational purpose only. Unfortunately, you can't see that. I got name, age, driver license, and member scenes. If I start typing, and then I got an email to show up. And if I change that to 12, driver license becomes disabled. And change that back to 19, that becomes enabled. Okay. Just to see this happening in real time, if I change this to I'm writing C# code and changing the condition. I'm hitting F6 to do a compile. It's going to take a while because it's actually compiling all 44 projects in the background. And because our code gen is really tightly coupled with our project infrastructure, it recognizes namespaces, project file hierarchies, and uses a lot of convention-based approach. So unfortunately, I can't really easily pull this out as a standalone project to demonstrate that. Let's just wait until this is finished. Well, what we're actually doing is we hook it into the post-build and to call a command script and to generate all the necessary files. And I'm expecting a build failure because the build modify some other files. When we check in this, we want developers to check in all the generated file as well. So we don't want a build machine to generate those files. So we want developers to generate those files and check them in. And because the build is going to rerun the whole process and replace the developer generated file. And if there's any code change or any content is different, we'll raise a compile error saying that, hey, you probably missed out something. And you can go back and review. But I can keep going with this. So I type in some name, the email shows up. If I manipulating the age, driver license become enabled, disabled. And if I say make it really large, can you see it's become disabled? Unfortunately, this screen, so you still can't see that. I think it's probably the same problem that I had before. Let's try clear the cache and do it again. Okay, there we go. So that becomes disabled. So what really demonstrated here is developers are putting conditional logics in here, and they get pushed out. And you can do whatever functions method in here, as long as you want to support them. So I can do string starts with, I can do ends with, contains, index of. String operations are pretty common, and you want to do that. Or some of the number operations, doing square roots, and those sort of things. And even some custom functions like ABC. And as long as I have ABC that written in JavaScript, and only needs to be written once, and then I can call that JavaScript function and get some evaluation back. That's it. Are there any questions?
You mentioned before that you had some user controls in your original product. And did you use any sort of other third-party controls or anything like that, or was it required specific development effort to bring that across the web?
Previously in Windows, I think we use Infragistic controls. But in web, we use Kindle UI, mostly for grids and date pickers. Yeah, of course, those sort of control side of things are the primitive thing. We have a framework team and a web team that developing those controls. And we create knockout bindings that can talk to those controls, can interpret data, and can parse user inputs. So things like this, on a short age, if it's a financial text boxes for amounts, I can type in 2K or 3K, that expands to 3,000. Things like that. We're developing those controls, but only needs to be done once. And inside the writer page, so it doesn't matter what control, what property that they are, what the type are. You just say render control for name, render control for email. The name is string, email string, age is number, but the template knows which template to choose from and how to create that control. And all developers have to do is that to list out all the control fields and then group them logically inside panels or field groups, and throwing additional buttons on the form, then done. Yes. Any more questions? Sorry, the first part of the statement, can you repeat that?
Yeah. What I'm trying to say is that it seems to be quite a sophisticated approach. And it seems that you put quite a bit of planning into it. So I guess there must be quite a direct
Absolutely. We had a very good 6-month head start in the architecture team. So that we planned everything, we developed a framework, and we tried to develop all the controls, all the building blocks. And also, we've been running the code generation, the Roslyn parsing, the code generation with some simple forms to start with. So we can learn from this migrating those simple forms, and then to perfect the Roslyn code generator. And I think after 4 or 5 forms, we pretty covered all the scenarios. And then after that, we can mass generate them and get just one developer assigned to one form and get them converted.
And when you brought on that one developer, I suppose you would train them into the techniques that you were using.
Yes, yes.
You want them if they try to down their journey.
That's right, yes. We do have a decent sized web team, 18 developers you saw. So yeah, currently many of them are still writing C# code just to do the form conversion, but they're also still writing a lot of TypeScript and JavaScript, and they are very good web developers. Because you still have to cover all the buttons. We're only talking about form fields, so you still have to have to program save buttons, do some financial calculations, those sort of things. So it still requires a bit of web knowledge. But for the Windows backend product, so we have been running the project for 1.5 years, and we certainly had new features being added into the Windows product, and that needs to be migrated to web as well, because the forms have already been migrated. We don't want to branch them out, we want them to converge. So we asked the Windows developers to put those new features into web. And for 1.5 years, not a single one of them have to touch JavaScript at all. And maybe a good thing, or maybe a bad thing, but from a business point of view and project migration point of view, it's a good thing. I think it can get the job done faster.
So you obviously gone from traditional Windows forms to web. Now we've got Windows Ultimate or Universal. Do you have a product branch that targets that framework as well?
Windows Universal now currently, you see this PC here is still running Windows 7. In our world, stuff moves a bit slower than the other topics that are presented in Ignite. So you don't see that I'm mentioning Azure or IoT. So, and just about 2 years ago, we had to support IE8. A year before that, we had to support IE6, unfortunately. But now it's fine. We fully committed to HTML5 browser, modern browsers. But we don't have any plans to support to create universal apps. Even if we do, it won't be a full-scale app like this. It will be a portal that targeted for specific users. So we have a mobile app that targeting the on-the-field consultants that bring their iPads or phones that talk to clients and recording client information, putting the quotes based on some very basic parameters, and then we can give clients a quick quote. But then the quote pushes into this is a core system and to do additional calculations.
So when you were considering the evolution of that product, you sort of decisions obviously made, well, Windows desktop applications are all past now, what are we going to do? Where's the obvious way forward?
Okay. Yeah, with this approach, that's already factored into the decision making when we started the project. It's like, Windows back then was very hot, and we're writing desktop apps, and now web is really hot. We're writing web apps. Who knows, 10 years down the track, what's hot? I can't tell. But at least when we consolidate all the logics into a centralized place, it's much easier to use tools like Roslyn to really harness the language and also harness the product. So you can use this to migrate to whatever next big thing is. That's the goal, at least. But how difficult it is depending on how well that we've done this.
Did you have to make any changes to the database at the end of all?
No, we don't have to make any database changes. In fact, we don't make any business rule changes because we clearly identify this is a migration project, not a rewrite. So, yeah, anything that we have a business facade here, and anything below that we're not touching. So we only touch the front end and also the APIs. Sorry, the data access, we use WCF as a host inside of Windows services at the moment. Yeah, we plan to move the hosting to IIS, but that's a separate topic. Yeah. Cool. Please remember the session evaluation form, so you can get into some prize draw, and I can get feedbacks from you about my speaking. Thank you very much.